We live in a world full of data. More granularity, more sources, and more pressure on demand planners. Their job is harder today simply because of the volume and diversity of information they have to work with. Traditional statistical models built on single historical time series don't always reflect the realities of the industry. So today, we'll explore how a global life sciences organization transformed its forecasting process by using customized machine learning, not as a replacement, but as a high-value input into an existing process. Let's set the context. Our client generates an 18-month statistical forecast every month. That signal feeds directly into production planning. Our goal was clear: improve the performance of that signal and optimize the planning process. We enhanced the statistical forecast using machine learning, and we modernized the demand planning workflow across the different tools used locally in each country. Now, if we look at the architecture, the machine learning model sits right in the middle of the ecosystem. On one side, we have a wide set of inputs: internal data, external data, multiple databases, all integrated into a central platform. On the other side, we have multiple outputs: SAP, FutureMaster, Power BI, Excel files, and so on. Machine learning becomes an additional layer that adapts to any input, any output, and any process. It doesn't disrupt the ecosystem, it strengthens it. Now let's zoom in. The model is built in 7 steps. 4 of those steps are fully customized to the company's data. The other 3 are partially customized, based on our experience with similar use cases. The first step is data collection and feature creation. A useful way to think about it is this: a data point might be something like a product size. A feature might be a binary variable, such as small or as large, which lets the model test its correlation with monthly sales. The next 3 steps are technical and iterative. We select the model, tune parameters like tree depth, define backtesting periods, measure performance, optimize, and repeat. Once the machine learning output is generated, we frame it. We apply minimum and maximum thresholds based on the statistical signal to avoid extreme values. And then we adapt the results to the specific formats required by each system. Now, let's take a closer look at the feature engineering step. The strength of the solution really lies in the feature engineering. This is where we define the model's DNA. Think of features as molecules. We decide whether they belong in the DNA, and if they do, where they sit. The higher a feature ranks, the more it influences the final forecast. The final DNA includes a balanced combination of sales patterns, seasonality and trends, inventory levels and shortage history, marketing actions and promotions, pricing and product attributes, external indicators like COVID indexes. Together, they form a complex but fully explainable mathematical model. Let's now look at a web app demo illustrating how demand planners can use this signal in practice. Across countries, demand planners access the machine learning signal through their usual tools, whether FutureMaster, Excel, or bespoke web apps. The interface varies, but the principle stays the same: a collaborative space where planners can review, adjust, alert colleagues, assign actions, and create scenarios for validation. Across all these tools, we consistently find 3 core elements: performance KPIs, accuracy, bias, stability, time series charts showing different baselines and historicals, override capabilities, adjustments by month, by SKU, or through mass updates at any level of aggregation. Key users can also decide whether a product is fully automated or handled manually. This lets planners focus on the materials that truly need human insight. So, how is the patient doing? The results speak for themselves. Our client improved its forecast accuracy, reduced finished goods inventory, increased fill rate, and increased revenue, all at the same time. Put simply, they produced less, sold more, and improved product availability for patients around the world. For the demand planners, the benefits were equally clear. High levels of automation reduced time spent on data manipulation and freed up time for communication and decision-making. The forecasting cycle, which used to take weeks, now takes days. It is faster, more robust, and easier to use. And the key message is this. This is not just an AI initiative. It's a deep transformation of the forecast process, grounded in the realities of the life sciences industry, tailored to each company and each country, and focused on delivering real operational value.